Okay, so in this video, we're going to talk about writing the equations of lines that are either parallel or perpendicular to other lines. So just a quick refresher here. So what makes two lines parallel? Maybe think about it for a second. So two lines are parallel if they have the same slope. And then what makes two lines perpendicular? Well, two lines are perpendicular if they have opposite reciprocal slopes, and sometimes people forget what that means, so just as a really quick example. So let's say I've got these two equations here, so y equals 2/3 x plus 7 and y equals -3/2 x minus 3. So in the first equation, the slope would be 2/3, and the second one, it would be -3/2. So this is what I mean by opposite reciprocal. So notice 2/3 and 3/2, those are reciprocals, and then one is positive, one is negative. That's what I mean by opposite. So that's what we're looking for with perpendicular. Okay, so what we're going to do, we're just going to jump right into the problems here, and we're going to try to write the equation of a line with the given conditions. So here is the type of example we're going to be looking at. I want to find a line that is parallel to y equals 3x plus 1, that goes through -2, -6, and I want to write that line in slope-intercept form. So here's the thing about these types of problems. You want to look at them in the right way. So there's actually three parts to this. The part about being parallel, so this is about picking out the slope. Then the idea of going through a particular point. This is kind of the second part of the problem. And then the third part of the problem is making sure that it's in slope-intercept form. So I'm going to color code this problem as I go through it, just so that you can see how each part of this relates to kind of these directions, if that makes sense. Okay, so let's start off by talking about making a line that's parallel to y equals 3x plus 1. Okay, so the thing that I want to note here before anything else is what slope does this line have? This line has the slope 3, right? So 3x plus 1, this will just be 3. And so what I want though is I want to figure out what slope do I need. So here's the slope that I have. If I want to get a line that's parallel to this, then that means I need the same slope. So just as a note here, so this is the line that this is the slope that I have, and that's also, in this context, that's the slope that I need. So take a second to actually think about this. Okay, so really the whole point of this first part is just figuring out what is the slope that you need. So we figured that out, so we're good to go. So now I want to talk about how do I figure out this line that goes through -2, -6. Well, this is going to be dependent now on understanding kind of these forms of the line. So I use in my videos the point slope form of a line. And by the way, if this is your first time seeing this, you might want to watch one of my videos on the point slope form just to kind of get the general idea behind it. I will drop a link to it in the description. Okay, so anyway, so you might want to watch the video on the point slope form. And then from the point slope form, we use that to either put lines in slope-intercept or standard form. So I just have a really quick cheat sheet here. So if you want to pause the video to write these down, go for it. So what I'm going to do now is I'm going to say, all right, so look, I have a slope and I have a point. So I can use my point slope form of a line, which is this, and I can use this to kind of get the party started and get this relevant information in. So plugging this in, I'm going to have y minus -6 equals 3 times x minus -2. Okay, so if I just simplify this, this becomes y plus 6 equals 3 times x plus 2. Okay, so now I've got all this information, and I've basically written the equation of a line that has the slope and the point. And now for the third part of this problem, I need this equation to be in the slope-intercept form. So just as a reminder, so the slope-intercept form, that's my mx plus b form. So what I want to do now is I basically want to solve this equation here for y. So to do that, I first need to distribute this 3. So this is going to be y plus 6 equals 3x plus 6. And then I will just finish solving for y by subtracting off the 6 as shown. So my equation here will just be y equals 3x. Notice that the 6's drop out. I don't need to write the plus 0, so this is good enough, so I'm good to go. So this would be the equation of a line that is parallel and goes through this desired point. Now, a quick sanity check here is just that they have the same slope, which is what they should have for parallel lines, so we can see that we're good to go. Okay, so that's kind of the idea behind this. Let's do another one now. So now what I want to do is I want to find the equation of a line that is perpendicular to y equals negative 2/3 x minus 5. That goes through the point 6, negative 2, and I want this to be in standard form. So once again, I just want to break this problem down really into like 3 parts so that you can really think of this as 3 different pieces. Okay, so starting with the first piece, so we want to figure out what is the slope that we actually want in this situation. So I always like to break this into 2 pieces. So starting with the information that I was given, what is the slope that this line has already? Well, this line has the slope negative 2/3. Okay, so I'm going to note that, negative 2/3. But in our situation, what is the slope that I need? So you have to think now, you need a perpendicular slope, which means I need an opposite reciprocal slope. So I need to manipulate this slope to be the opposite reciprocal. So for this problem, I need the slope 3/2. So this is why it matters whether it's parallel or perpendicular. It's going to help you to figure out what kinds of slope that you need. So you want to just take a second to kind of write all this information down and process it. So once you figure out what slope you need, then you can really move on to the next part of the problem about using this slope and this point. Okay, so now what I want to do is I want to use that point slope form like this, and I want to use the slope and the point, that information. So let's plug it in. So this is going to be y minus negative 2 equals 3/2 x minus 6, and then I'll just simplify that to y plus 2 equals 3/2 x minus 6. Okay, so now I can go ahead and kind of move forward with this problem. I have my point and my slope in an equation, and now I need to get that equation into standard form. And so standard form, so just as a reminder, standard form is ax plus by equals c. And a, b, and c, they cannot be fractions, so that will matter later in this problem. Okay, so to get this party started now, what I want to do is I want to distribute this 3/2 into the set of parentheses. So this is going to be y plus 2 equals 3/2 x. And then just as a reminder, so I've distributed here. So if you have trouble figuring this out, 3/2 times negative 6, you could always just work it off on the side like this. So 3/2 times negative 6. So remember, this negative 6 is over an invisible 1, so this will come out to negative 18 over 2, which will ultimately equal negative 9. Okay, so this will end up being 3/2 x minus 9. All right. So now we have kind of a choice to make here. With standard form looks like this. The x and the y have to be on the same side, but the big thing is that you can't have fractions in this. So look at the problem that we have. Right now we have this big old fraction right here. So I've talked about this in another video too, but I'll explain this here. If you want to get rid of the fraction at this step, you can. So to get rid of the fraction, what you will do is it's the very similar technique as to like working with equations and clearing out fractions. It's the same idea. So I want to multiply every part of this equation by 2 because that will help me to keep the equation balanced. So I can't have the equation balanced if I don't multiply everything by the same thing. So I've maintained my balance here. But now multiplying by everything by 2, what happens is that 2 will cancel out with this 2. So we literally multiply by the denominators so that we can cancel out one denominator. Now the consequence of this is that everything else has to get multiplied by 2, but at least we got rid of the fraction. So now I've got 2y plus 4 equals 3x minus 18. Okay, so now I can continue to work to get this into standard form. So what I want to do here is I'll go ahead and I'll subtract off the 4, and let me clear some space over here. So now I'm left with 2y equals 3x minus 22. And then I can subtract off the 3x to get negative 3x plus 2y equals negative 22. And so now look what I have. I have this equation in standard form and I don't have any fractions, so I'm good to go. So that's the type of equation that I want. Okay. So let's keep going with this. Let's do another one of these together. I have a bunch of these examples, so I know sometimes these can be kind of tricky. So practice makes perfect with this particular stuff. Okay, so once again, so I want to find a line that's parallel to 2x minus 3y equals 6. It has to go through this point, and I want to have this in slope-intercept form. Now, there's a little issue with this particular problem. Notice that when I look at 2x minus 3y equals 6, this is not in slope-intercept form, so we cannot see the slope easily here. So what we're going to have to do is we're going to have to manipulate this equation, which is currently in standard form, and we're going to have to manipulate it so that we can actually see what the slope is. So I want to first start by putting this into this y equals mx plus b form. That's kind of what you want to do if you don't have that. So starting with 2x minus 3y equals 6. So I really just need to solve for y, right? So let me start by subtracting off the 2x. So I get negative 3y equals negative 2x plus 6. And then I'm going to divide each part of this equation by negative 3 to get y equals 2/3 x minus 2. Okay, so that was a lot of work. And remember, we're only on the first part of this problem, right? So really, I'm just trying to figure out what slope do I need. That's what the first part of this problem is all about. So notice that this equation has what slope? What is the slope that we have? 2/3. Okay, and for this problem, what is the slope that we actually need? So now I can see what slope I have, and I need a parallel slope. So to be parallel, I need the slope 2/3. So the same slope, right? Okay, so now I've got kind of that first piece of information. So let me clear this all off. And now that we figured out what slope we need, we can pivot to the next piece of information. So now we have our slope and we have our point, so I can use my point slope form. So I can plug in this information. So this is going to be y minus negative 2 equals 2/3 times x minus 1. So this will simplify to y plus 2 equals 2/3 x minus 2/3. Okay, so now we have kind of done what we need to do to get the point and the slope in the point slope form. So now we're going to pivot to the last part of this problem, which is now I want to get this into slope-intercept form. So remember, my slope-intercept form is y equals mx plus b. There's nothing about this that says you can't have fractions. So the thing about not having fractions only works when you are talking about standard form. In this case, we can have fractions, and we're going to have fractions. So to finish solving for y here, all I have to do is subtract off the 2. But notice what's going to happen with this. Now I have to do negative 2/3 minus 2, and maybe I want to have this as an improper fraction. So we're just going to have to take a second to work this out. So negative 2/3 minus 2. Well, remember, I can write 2 as a fraction over 1. So right, I can write 2 over 1, that's the same thing as 2. And if I want to actually do this calculation, and I want to have a common denominator, what I need to do to this is I need to multiply by the desired denominator. So the denominator that I want is 3, right? That's driven by this part here. I want this denominator, so I'm manipulating this guy here to get that denominator. So I multiply this by 3, and whatever I multiply the bottom by, I have to also do to the top. So here's how I get my common denominator. So this is going to become negative 2/3 minus 6/3, and then this equals, so now I'm good to go, really. So now I could just subtract the tops together. So negative 2 minus 6, this will be negative 8/3. Okay, so that was the answer to this negative 2/3 minus 2. So now I'm really good to go here. So my answer is going to be y equals 2/3 x minus 8/3. And so, like I said, because we're dealing with slope-intercept form, it's okay to have fractions. We have fractions, so we're just going to have to go with it. Okay, so now let's take a look at this next example. So again, I want you to start thinking about this in terms of like 3 phases. So the first phase is figuring out that slope that we need, so figuring out something that's perpendicular. And then the second phase is going through this point. And then the last phase is getting this into standard form. Okay, so what I want you to do is I want you to determine what slope do we need in this case. So notice that I've got this 2x minus 4y equals 8. Once again, this is not in slope-intercept form, so you can't just look at this and figure out what the slope is. So why don't you take a second to rewrite this in slope-intercept form and then hit play when you're ready. So to get this into slope-intercept form, I'm going to go ahead and subtract off the 2x like this. So I get negative 4y equals negative 2x plus 8. And then to finish solving for y, so I divide each part by negative 4. So now I get y equals, this is going to come down to 1/2 x minus 2. Okay, so the next thing that I want you to do now is I want you to pause for a second and figure out what is the slope that we need in this problem. So take a second to think about it, hit play when you're ready. So notice that this line has the slope 1/2, but what slope do I need? So if I'm thinking about what do I need something perpendicular. So something perpendicular to this would be negative 2 over 1, right? Because it's the opposite reciprocal, and so that's just going to be equal to negative 2. So that was a lot of work to get the first phase of this problem done, but now we've got the slope that we need. So let me clear this all off, and then we'll continue on with the problem. Okay, so now that I have my slope, now I can take in the next piece of information. I've got my slope and I've got my point. So I'm going to use my point slope form to put all of that information together. So plugging this all in, I get y minus negative 2 equals negative 2 times x minus negative 4, which this will simplify to y plus 2 equals negative 2 times x plus 4. Okay, so I've got all that information now in that format that I want, and now I have to get it in the desired form, which is standard form. So I have to now manipulate this till I get it into standard form. So first things first, I've got to distribute this negative 2. So why don't you pause the video here and see if you can get this into standard form, and then hit play when you're ready. Okay, so this is going to be y plus 2 equals negative 2x minus 8. And so then I'm going to go ahead and subtract off the 2 as shown. So I get y equals negative 2x minus 10. But I need this in standard form. So then I'm going to go ahead and I'm going to add the 2x like this. So I get 2x plus y equals negative 10. And so that is my answer in standard form. Okay, so moving on to the next one. So now I need a line that's parallel to 3x minus y equals 12 that goes through this point and is in slope-intercept form. So once again, just for best practice here, so I need to figure out my slope, and then I need to have it go through this point, and then finally I need to get it into slope-intercept form. So let's start with the first part of this. So why don't you pause the video here and see if you can figure out what slope is it that we need, and then hit play when you're ready. Okay, so I've got this 3x minus y equals 12. So again, this is not in slope-intercept form. So I still have to do that manipulation where I subtract off the 3x. And so I get negative y equals negative 3x plus 12. And then I need to divide each part by negative 1. So I get y equals 3x minus 12. Okay, so now I need to figure out what slope do I actually need. So notice that I have the slope that this line has is 3, but I need one that's parallel. So the slope that I need is also 3. That's for two parallel slopes, they have to be the same thing. Okay, so I've got the slope that I need, so let me clear some space. Okay, so now I've got my slope and I've got my point. So why don't you go ahead and put this into point slope form and then hit play when you're ready. So I've got my point slope form like this, and so I'm just going to plug in the information. So this is going to be y minus negative 5 equals 3 times x minus negative 1. So this will simplify to y plus 5 equals 3 times x plus 1. And so now, why don't you finish this problem? Again, you can pause here and get this into slope-intercept form, hit play when you're ready. Okay, so to finish this, so now I've got y plus 5 equals 3x plus 3. And then all I have to do to finish this off is to subtract off the 5 as shown. So in slope-intercept form, this is going to be 3x minus 2. And so that will be my final answer. Okay, so last problem here. So I highly recommend, if you feel like you're starting to get this, maybe just pause the video and try the whole thing on your own. Otherwise, I'll walk you guys through it. Okay, so I need something perpendicular that goes through this point to -5, and I need it to be in standard form. Okay, so first things first, find the slope that we need. So you got to put this back into that slope-intercept form and all that good stuff. So maybe pause here, hit play when you're ready. So I'm going to have -2x plus 3y equals 12. So let's see, I'll go ahead and add the 2x to both sides. So I get 3y equals 2x plus 12, and then I will divide all sides by 3 to get y equals 2/3 x plus 4. Okay, now notice that the slope that I have, this line has the slope 2/3. And now I need to think about, what is the slope that I need? The slope that I need is one that has to be perpendicular. Perpendicular means opposite reciprocal. So I need to flip this and make it negative. -3/2. Okay. So let's go ahead and clear all this off, and then let's keep going with this. Okay, so now I've got the slope. I've got the point. So let's go ahead and put this in point slope form. So again, this could be a good place to pause the video if you are kind of working this out. So I'm going to have, this will be y minus -5 equals -3/2 x minus 2. So I got y plus 5 equals -3/2 times x minus 2. So there's kind of all the information in that line. And now I have to get it into standard form. Now be careful with this. This is going to be a little tricky. Okay. So to finish this, I need to just distribute that -3/2. So I have -3/2 times x is -3/2 x. And then -3/2 times -2. So remember, you can always do this work to the side like this. So -3/2 times -2. So remember, this is over an invisible 1. So if I multiply these together, this becomes 6/2. This will equal 3. So that is what goes right here. Okay, so let me get rid of all that. And now let's keep this going. Okay, so now I'm going to go ahead and subtract off the 5. So I get y equals -3/2 x minus 8. And so now I'm going to bring the 3/2 x over to the other side, because remember, we're trying to get this into standard form. So I can add the 3/2 x like this. So I get 3/2 x plus y equals -8. But wait, we're not done. The whole thing about standard form is you can't have fractions. So this is a problem. So if you go through all this work and then you realize that you still have a fraction, what do? Well, you could just multiply everything by 2, like this. So cancel this out. So this will become 3x plus 2y equals -16. And remember, you have to multiply everything by that number to keep the balance of the equation. And so this would be my final answer, so that I'm good to go. So hopefully this video was helpful to you. If you have any more questions, you are always welcome to leave me a comment, or you can email me or whatever. But this is definitely a trickier topic, so it definitely requires a lot of practice. Don't be surprised if you have to maybe go back and rewatch the examples a few times to fully grasp it. That's totally okay and totally normal. Thanks for watching, guys. I'll catch you next time.